In this section, we'll talk about our conditions to use linear regression. So every test we've done in this class had conditions. So if we want to use a linear regression, we have to meet these following conditions. First, our data should follow a linear trend. If it doesn't look like a line, you probably don't want to use linear regression. Now, remember how we talked about residuals? Residual is the difference between your observed and predicted value. So if you were to find all of the residuals, they should look approximately normal. Okay? And the variability of points around our least squares line should be fairly constant. We'll talk about what each of these actually look like. And the observations should all be independent from each other. Okay, one shouldn't be affecting the next one. If any of these aren't going to work, you shouldn't be doing linear regression. Now, checking all of this actually gets very advanced. We have an entire graduate level course on how to check conditions for linear regression. So we're not going to focus on it too much in this class, but we can kind of look at some of the basics. So we often check at our residuals to see if our conditions are met. So remember, our residual, or our error, is the difference between our predicted value and our observed value. So our residual is observed y minus predicted y, or y minus y hat. What we can do is our software will make us a residual plot. It's a scatter plot of our residuals against our x values. Okay. So you'll have basically your x values here. You'll have your residuals on the y, and it'll be some kind of plot. Residual plots help us know how well our line fits the data. It can also help us know if a straight line was appropriate for that data. If the line was an appropriate choice to describe our data, there should be no pattern in the residuals versus x plot. So it should just kind of look like my points are just randomly scattered about. You shouldn't see a pattern. Okay. However, if you were to look at all of the residuals themselves, so not this plot, but if you were to look at the actual residuals, they should be normally distributed. So if you were to look at the residuals, they would follow a normal distribution. Okay. But we don't actually look at that plot. We'll look at a normal plot for the residuals. So here are some data sets with our scatter plots and regression lines and the residual plots. Okay. So you can see for each data set, I have the scatter plot and the regression line. I have the residual plot against x, and I have the normality plot to check the residuals. So when you look at the scatter plot, it should look linear. So for my first one, predicting home upkeep by value of the home, I have a line. The points all seem to be pretty close to the line. I have a pretty good R-squared value of 0.889. When I look at these residuals, they seem to look fairly random. And my normality plot looks fairly close to a straight line. I mean, it's not exact, but it's close enough. I'm not too worried about that. Okay. When we predicted our fuel by temperature, again, my points seem to follow a line. Or when I look over here, they look pretty random. There's not a lot of points, so it's kind of hard to tell, but I don't see any distinct patterns. And it's fairly close to a straight line. And when we predict fat gain by amount of exercise, looks like I'm close to a line. My residuals against x look fairly random, and that's pretty close to a straight line, so my residuals would be normal. Here are some data sets where linear regression is not going. So this is where it's more interesting, seeing things that are wrong. So this one is predicting life expectancy by the number of internet users. You can see that this does not look like a line in my scatter plot. It has some kind of relationship like this. So this is definitely not a line. So I should not have done linear regression. Even though, notice, Megastat still gives me results. Megastat doesn't check to see if it seems logical. Okay. Notice now when I look at my residuals that you see a kind of similar pattern. This is a very distinct pattern. When you see distinct patterns like that, that means your original data was not a line. So it's a distinct pattern, not random. So that's a bad sign. My actual normality plot, I probably wouldn't have actually seen that there was anything wrong here. Okay. So it's important to look at all of your plots and not just one, because sometimes it's easier to see something that's wrong in one plot than the other. Because this one, I mean, this is kind of a curve, but I wouldn't have looked at that and thought there was anything wrong. Here's an example I made with an outlier. So you can see if you had looked at the scatter plot, it was pretty much a straight line until I introduce that outlier. So that outlier is a bad sign. Notice in your residuals plot, I have the outlier still shows up. And those points don't look random either. And even in the normality plot, you still see the outlier. So we know that this is not going to work because that outlier is ruining everything for us. And then you might have remembered when I said the conditions, there was one that said you need to have a constant variability. So let's go back and read that one on the previous page. Okay, it said the variability of our points should be fairly constant. Okay. So what does that mean? It means if you were to kind of draw a band around your points, it should stay the same width. So this software, I got one that kind of drew a band around it. Notice how my points are kind of close to the line here, but they get farther away here and farther away here. So the variability in y seems to be changing. So the variability in y gets bigger as you go along the line. Okay, that's bad. You're supposed to have it kind of be about the same. So coming back up here, notice, I mean, it's not exactly the same, but it's not too bad. We're kind of, if I drew a band like this, it'd be about the same for the whole thing. I'm not changing as noticeably as I am here. Okay. And then in my residuals plot, notice it kind of looks like this and looks like this. So I start small and then I get bigger. So again, this is a pattern here. So anytime you see like distinct patterns in your residual plots, that's showing you that there's something wrong. And here my variability changed, so there's something wrong.